sometimes they might not be sold in a constant mix. So we want to check what if they are sold in order of profitability. Remember, for us to do this, we need to rank. Yeah. So you need to rank products. So I'm going to give you, before we go into this same scenario question, just to check your understanding and how deep you are. So I have, let's say I have two products, X and Y. My selling price for X is 40, for Y is 5. My variable cost is, which product is better? If you have to rank, which one will you rank first? Which one is more profitable? Think about it. This is your cost, right? If you spend $35, you will get $5. But if you spend $2.5, you are getting the same $2.5. So if you have $35, where should you invest it? Is it in X or in Y?
Y.
Exactly. So invariably, if you have $35 and you spend it on X, you get $5. You spend it on Y, you get $35. That's what it's saying. So which is the better investment? Obviously, Y. Usually, when you have to rank a product for profitability, what you need to calculate is contribution per sales. That's what you need to get. So what you need to calculate, like I was saying, is contribution per selling price. So I know your contribution here is $5, here is 2.5. What is the contribution per selling price?
It's 0.125.
0.125. Wow, okay. Then that's for X, and for Y, that's 0.5. So that's 2.5 over 5. Yeah, that's 1/2. You can see it's showing clearly that Y is better because it has more contribution for the selling price. And why is that ratio quite important? Because that ratio is telling you something very critical. Yeah, it's telling you how much you have left after you have deducted your variable costs. Yeah, which means how much you have left to absorb your fixed cost. That is what that ratio is telling you. That for every selling price, how much contribution are you making on top of it? It's like your return. It's like your margin in quotes. If you remember, we used to do profitability margin. What is the formula for profitability margin? It's profit over selling price. This is like a contribution margin. So you are going for product that has a better margin. So you don't take contribution in isolation when you want to rank products, right? But we want to rank two products. There is no other way than using your contribution margin to do it. Yeah, which is the same thing or similar to your profitability margin concept that you know, profit over selling price. But this time around, it's going to be contribution over selling price. Yeah, because that is what shows you how much fixed cost your product is able to absorb. That's exactly what it's showing you. Because the more you're able to absorb that fixed cost, the more profitable you are getting close to. If you absorb it, finish, you still have more, it means that you're even seriously profitable. So that's what we're going to do. So now we'll go back to our scenario, this one, and now we need to rank it because now it's no more in a constant mix, but it's now in order of profitability. So which means we need to get that order quickly. So what's our contribution for each of these guys? So we need to get our contribution. Quickly give me the contribution for ABC.
We have 10 for A.
10 for A.
4 for B.
4 for B.
And 2 for C.
And 2 for C. And what is contribution to selling price? Which is the contribution margin?
So can you scroll back up a bit, please?
16, 12, 12. 16, 12, 12 is the price. So 10 divided by 16, divided by 12, divided by 12. What is that?
A is 0.63.
0.63. What's B?
0.3.
Yeah.
Yeah. C?
0.16.
6.
So now we need to rank. Which one are we going to sell first?
A.
Yeah, A.
Okay, so we're going to sell this first so that we can
And-
maximize our profits. Then this one second, then this one third. So that's how we're going to sell it. Now that we know how we're going to sell, then we have to plot the graph. Yeah, because if we are able to sell in sequence, it's not going to be the same the way we plotted the previous graph that is in a constant mix. We went straight to the maximum units. Yeah. Now it's going to be different because we're going to plot almost for one line, it's going to be 3 sections. A section for A, a section for B, and a section for C. Because we're going to sell unit 4,000 of A before we sell 8,000 of B, before we sell 6,000 of C. So pay attention to this so you don't get confused at all. So first of all, what we know is that in terms of units, there will be 3 steps units. Yeah, A, B, C. So we're going to sell 4,000 of A first before we sell 8,000 of B, before we now sell 6,000 of C to now accumulate into 18,000 units in total. Right. So which means we need to sell up to 4,000 of A. Then to sell 8,000, it means that we move to, where do we move to? What point?
12.
Yeah.
12.
Because that is 8,000 of B.
Mm-hmm.
Then to sell 6,000 of C, I have to move to 18. So this is C. But I now need to get the dollar equivalent for everything that is happening. It's still the same graph we are plotting, the traditional graph, which means we need to get the total cost, we need to get the total revenue, and the fixed cost. Right. So the fixed cost is super easy. This is where we need to be careful. Yeah, so we're going to be getting to the maximum point that we only got for total cost, maximum and minimum. We got it just once. This time around, we'll be getting it for each of the products and be joining them together. And watch the way we're going to plot it. So which means for each sequence, we need to do what we did just once for each sequence in this scenario. So let's say we want to deal with total revenue first. Total revenue first. So for total revenue, we need to get it for A. So I'm going to start with A. That's our first sequence that we need to sell. So total revenue, we need to get the minimum and the maximum. So tell me what's the minimum revenue for A? It's 0. So remember, we are one company, we are selling A, B, C. So if we are starting from A, by the time we are starting from A, what will be our minimum revenue at that point in time?
0.
0. So that will be the minimum that we will be selling because we have not made anything. Then maximum at that point will be what? But that's the point when we have sold the 4,000 units of A. And that means that will be 4,000 units times price of A, which is 16. So that means the maximum revenue from A will be 64,000. And we can, ourselves, we should just start plotting it. Let's just plot it. Yeah, we already know that the maximum revenue will always be 232 where we get. So let's use the same approach we used. But maybe we should use 40. Let's use even number this time around. 40. 80, 120, 160, 200. This is not enough because, oh, it's not 240 because I think the maximum was 232. Okay, so we know that our fixed cost is 20. That's not changing. Regardless of whether you are selling in sequence or you are selling in constant mix, fixed cost remain fixed cost 20, right? But now we now need to sell A first. And revenue line will start from 0 for A when we have not sold anything to when we have sold 4,000. And at that point, that will be 64,000. And this is a 60 line. So I'll just put it on the 60 line. And 4,000 units, right? And we just slightly up. Then I can plot that A revenue. So I'm going to join A revenue. So this is A. So that's A. Yeah. Let's finish the revenue line so that we can plot it step by step. So let's go to B. For B, by the time we are selling B, what will be our minimum revenue? By the time we decide to sell B?
64.
Exactly. Because we must have sold 64 worth of A before we can go to B. So then the maximum will now be that 64 that we have already sold plus the total unit of B that we plan to sell, and that's 8,000 units. Multiplied by the price of B, which is $12. So 8 times 12 is what? That 96. Yeah, 96. The 96 plus 64. What's that? Use your calculator, help me out with that.
160.
160 is my calculation correct? 8 times 12?
Yeah. That's it.
96 plus 64. 160K. So which means to continue the path for B, the minimum, yeah, will be here. And the maximum will be when we are done selling the 8,000, which will be at 12 and 160. So I need to join the line for B. You can see it's no more a straight line. And that is because we are selling in sequence. Then we need to finish with C. For C, what will be the minimum revenue? That will be where we stop because we must have finished selling both A and B before we can sell C. So minimum will be 160. That's the point where we have 0 unit of C. Because at 0 unit of C, we have 160 revenue. And maximum of C, we would have sold the 8,000 units and 6,000 units of C at 12. So the 160K that we already have at the minimum plus that's $12 multiplied by 6,000 units. Yeah, because we're selling 6K unit of C, right? Let's just quickly check. Yes, 6K. So what's the total? What's the maximum revenue for C? At that point, when we have sold C, what will be our maximum
232,000.
revenue? What?
232,000.
232,000. Yeah. Because at that point, we have sold all of A, all of B, and all of C, which was the same maximum we had when we were selling in constant mix, right? The maximum will always be maximum, right? So that is at 18. However, 232. So if this is 220 at 18, 220, this is 230 somewhere. So we need to join that. And that's our total revenue line. So we have just one more line to draw, which is the total cost line. And we need to do the same thing for ABC, total cost line. And it's going to follow the same approach. For A, we need to know the minimum and the maximum. So at the point when we're planning to sell A, what's our minimum total cost? That's our fixed cost of 20K. You agree with me, right? Do you agree? Maximum
Yes, sir.
will be that 20K plus the variable cost. And variable cost of A is $6. And we're selling how many units? 4,000 units. So that's 24,000. So the maximum equals to $44,000. Yeah. So which means we need to plot that. So starting from here, minimum to where we have 4,000 to 44. So that is 44. This is 60. This is 50. Right? So 44 is like 45, which is like half somewhere here. So we need to join those 2 points, and that's our total cost line for A. So this is the 2 points we're supposed to join. Yeah. Yeah. Thank you. So that's the total cost line for A. For B, we said minimum is 44K, but maximum will now be 44K plus its own variable cost at max. And that's selling how many units of B? We're selling 8,000 units of B. And the variable cost is $8. So that's plus 64. And that will give us, what's that? 108. So which means we'll have 108 at the max of B, which will be 12. That's 0.12 because at 0.12 we would have sold additional 8,000 units on top of the 4,000 that we sold for A. So which means that will go to 108. And where's our 108? This is 80. This is 100. So I'll just put it somewhere here as 108. So we need to join that for nice color. Let's use this one. That's the total cost for B. And lastly, for C, it's just your maximum total cost that you have before. Minimum remains at 108, which we already have there. Then the maximum is 108K plus the variable cost of C. Yeah, at the maximum units, which is 6,000 units, multiplied by variable cost of $10. And that gives us the total maximum of 60K plus 108, that's 168K. Yeah, so which means at 18,000 units, because additional 6K unit of C takes us from 12 to 18, Then we need to go to 168, which is about this is 180. So if this is 180, 170, somewhere in the middle. So I can put it there. Let me look for another nice color. Yeah, that is the graph. So you see that, in fact, let's put it side by side. So this is sequence, and this is the constant mix. Here, look at it. This is the breaking point. If you are selling in sequence, which means you practically need just how many units to break even if you are selling in sequence? Your break-even units is about how much? Can you see on the graph?
Yeah, 2,000. What's that?
Exactly, about 2,000 units. Because that same 2,000 units will make you break even. And at that point, this is a total cost. Let me label it. At that point, your total cost and total revenue will just be around, if that is 40, that's just about 30K or something. Yeah, because this is 20, this is 40, so the middle is about 30K. That's about 30K of revenue and total cost. So looking at these two graphs, what comes to your mind in terms of the difference between selling in sequence and selling in a constant mix? Or maybe I should ask in an easier way, which one do you prefer the company to do? Should they sell in sequence or they should sell in constant mix? If you have to advise the company.
In sequence.
In sequence.
Mm-hmm.
Why should they sell in sequence?
Because the break-even point comes earlier.
Fantastic. That is the question. That's the question I was asking. Because you are going to break even earlier when you sell in sequence than when you sell in constant mix. It's not always going to be like that. Or it might not always be like that. But at least for this scenario, what we can see, because you can also have two graphs and examples and they say, advise the company. Yeah, so you need to know the points you want to look into to be able to advise appropriately. So for this company, it's better to sell in sequence than to sell in constant mix. Because when they sell in sequence, they are able to break even earlier. And that is it. You can see that it looks easy or looks okay, but if you don't practice this thing, forget it. Forget it.
Sir, you said the assumption is always that we always assume that there will be a constant mix, right?
Yes, when you are doing a calculation. But I said once you are doing graphing, you make the second assumption that is you can be asked to assess the company with an assumption that they will sell in sequence or in order of profitability.
Oh, okay. That's when graph is involved.
Yes, when graph is involved.
Okay, but in exams, mostly they will give us the graph, not plot the graph, right?
Yeah, they will give you the graph, but if you don't know how to plot the graph, you cannot use the graph in exams.
Yeah, I get that. Okay.
Yeah. So I will tell you that you must learn how to plot the graph.
Mm-hmm.
That is it with the graphing. And practically almost end of that chapter. And the last thing which I'm just going to touch on quickly is the last part of the chapter. That's talking about the limitations of this analysis. What are the limitations? Remember, everything that has an advantage has a disadvantage. What's the advantage? It helps us to do analysis of how different levels of activity can affect profitability. That is the advantage. That is the usefulness. Because activity level can vary, but how can we vary that activity level and see the impact on profitability? This CVP analysis, that is what it helps us to do. But does it mean that it's perfect? No, it's not perfect. There are disadvantages. And you can actually guess those disadvantages. These disadvantages are usually based on the assumptions. Anything that's making assumptions, you need to be checking, are those assumptions, will they always be valid? Most likely they will not always be valid. So even if you cannot remember disadvantage of anything, if that thing is based on assumption, attack the assumption, that the assumption will not always be a reality. And that is the first limitation that we're going to be attacking. Because remember, the first assumption we made when we're doing this was that variable cost, fixed cost, price will be constant. We said selling price, variable cost per unit, and fixed cost, they are always constant. This is not so in reality. Because even your variable cost per unit can change. Yeah? If there is bulk purchase discount, your material cost will not be constant per unit. Your vendor might say, if you buy 10,000 units, I give you some discount. Or they might say, okay, we are even doing a promo or promotional sales. Come and buy more. We are selling at a discount. So the selling price, the variable cost will not be constant because the material cost has changed. Even fixed cost will not be constant because there can be a step up fixed cost. It's not all the time that your fixed costs are always constant. So that assumption is the first thing we're attacking because it's not always so in reality. Also, it doesn't do so much justice to uncertainty. Though, yeah, margin of safety a bit, but not enough. So I would say let's focus on uncertainty. Yeah, margin of safety is not enough for risk management. Yeah, in that case. So if you look at that plus the assumption of constant mix, is that always going to be so? In fact, I don't know any company that sells in constant mix. I've never seen. I don't think it will ever exist. So this is just pure theory. Most times, companies will sell in order of profitability. Because why should I be selling a product that is not giving me maximum profit? I want to exhaust my most profitable product first before I go into the less profitable ones. So this constant mix assumption is weak. So you can imagine as fantastic as the analysis is, we've just rubbished it. Right? So you need to know those disadvantages as much as you know how to do the analysis. Any question? And that is it for CVP analysis. One more advantage for CVP is that because you use graph, right? Another advantage that I said the first advantage is that activity level impact on profitability can be examined, right? Using this. The second advantage is that the use of graph, allows non-accountants to understand. Because if you are very good with mathematics, looking at the graph, you can actually interpret a lot of things. So that's also an advantage for that CVP. Yeah, and also the disadvantages are there. I think it's a good way to end it.